Okay, now hex is counting in 16s. Okay, so we normally count in denary. So you can see in this column here, we've got denary. So because it's base 10, the largest digit we can have in a single column is 9. Because when we add 1 to 9, we get a new group. We've got a group of 10. So 1 needs to go into the tens column, and then we've got no units here. Okay, so that's what happens. In binary accounting by base 2, so the smallest digit we can have is 1 less than 2, which is 1. So we've only got zeros and ones. Okay, now in base 16, we've got up to 16. So we can have in one column a digit or a symbol that represents 16. So the issue that we have is that when we're counting up to 10, once we get 9, 10, we still want to use a single digit. And the single digit that we use letters instead. So when we get to 9, we say A, B, C, D, E, F. So F actually represents 15. Okay, so it represents 15 in base 10. So, but it represents in hex, when we count in, it's a single digit. It's what we use to represent a value in a column. Okay, because once we get up to 16, that's a new column, and we add 1 into there. So this table shows you all the denary values here. We've got all the denary values here, and we've got their hex equivalent. Okay, so if we were to write 16, we would write 10. So this goes up to 15, and it's 15 units, but we can only use a single digit. This column represents the binary equivalent in nibbles. Remember, a nibble is 4 bits. So the binary for 7 in 4 bits in a nibble is 0, 1, 1, 1. So it's a 1, a 2, and a 4. That makes 7. Now, there's a relationship between binary and hex, in that binary and hex are shorthands for each other. And we can write a binary number as a hex number by using nibbles, and we can write a hex number as binary by converting the nibbles. Okay, and we'll look at an example of how that works next.